12b, and in this I'm going to talk about reading quantified sentences, interpreting them. What do they mean? So what are some basic facts about quantifiers? So for this, the universal quantifier x symbolizes each thing as such that, and the existential x symbolizes at least one thing as such that. And they have these simple variants. So each thing is f, everything is f, all things are f. Our variants of each thing is such that it is f. Something is f, there is an f, at least one thing is f, are all variants of at least one thing is such that it is f. I'm going to now sort of give an official definition of sort of when a quantified sentence is true and false, but it's only a semi-official definition. It's not actually quite right. It's a simplification of the right definition because the complexities of the actual definition would lead us astray at this moment. So we'll come back and see what the official definition in its full glory is later. So universal in this case is very straightforward. We say for all x, blah, 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 x is true if and only if for each object that there is, blah, 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 x is true when O is assigned to x, when we interpret O as talking about object x. And the existential is the same, it's just that it requires that there be at least one object that when assigned to x makes that sentence without the quantifier true. So that's pretty straightforward. So if we have a sentence like x is less than 7, if we put some x on the front, we would symbolize that as some x f(x). So how would we figure out if that was true? Well, we take each object and assign it to x and find out if when we assign that object to x, is x less than 7 true or is x less than 7 false? And if we find an object where when we assign it to x, then x is less than 7 comes out true, then also some x is less than 7 is true. But if we do that for each object and it never comes out true, it's never the case that when you assign, for each object you assign it to x, and x less than 7 does not come out true, then we instead say that some x is less than 7, that's false, or some x f(x) is false. If we have a universal instead, then we take each object and again we do the same thing, but it's sort of reversed. So if it ever happens that we assign an object to x, and then x is less than 7 comes out false, then for all x is less than 7 is false. But if we never find such an object, if whenever you assign objects to x is less than 7, and x and 7 comes out true each time, then the universal quantifier, the universally quantified sentence, is also true. So basically it's saying something has this property, at least one thing has a certain property, or everything has a certain property. So we have x is a chair, x is an emu. Well, how would we symbolize that? Or so we could then say some x is a chair, x is an emu, and that would be some x, cx, or ex. And so we just take each object and assign it to x, and do we ever get true? And the answer is yes, we certainly do, because there are chairs. Maybe they're emus. For all x is a chair or x is an emu, so for all x, cx, or ex, that's false. If you assign me to x, I'm not a chair, I'm not an emu, so cx or ex comes out false when I'm assigned to x, and so the universal quantification is also false. We don't always get true when we assign an object to x. So this lets us sort of we can summarize what I've observed here, but, well, not summarize, but there are 3 important facts I'd like to point out to you about the quantifiers in logic, in the logical language. So 2 of them are grammatical facts. One is the grammatical rule for forming a formula with a quantifier. And it's that you take a quantifier and you put a formula after it and you get a new formula. And of course, a second fact is displayed here. So if we have fa, well, the grammatical rule says if you have, oh, that's backwards, but that's okay. If you have a predicate letter and then a name, you build a formula. But if you have a predicate letter and then a quantifier, that's not grammatical. Right? F of something, we don't do that. And so what this shows is that quantifiers do not go where names go. Quantifiers go in a different place. So we have quantifiers form a sentence in one way, names form a sentence in a different way. In particular, a quantifier hooks onto a whole formula, whereas a name hooks on just to a predicate. So they have different they are in different places in the grammar. names and quantifiers are. And then there's a semantic fact, which is that the quantifiers have unrestricted range, meaning that they concern all the objects in the world. Obviously, and we're going to see that that's, well, you might say, wait, I don't understand. I thought the existential is at least one. And that's true. But by concern, I mean you have to look at all of them to know. You have to look at all of the objects to know if the universal or existential quantification is true. If the universal, for the universal to be true, you have to say they're all the objects and the universal is true of each single one of them. For the existential to be true, there has to be at least one out there that has the property. And so if the existential is false, then none of the objects have the property. So the existential quantifier cares just as much about all of the objects as the universal does. It just asks less of them, if that makes sense. At least one of all of the objects, or just all of the objects, have to make the formula true. So if you, one way to see that is to say, I say, something is orange. And I think, well, let's see. This is not orange, and this is not orange, and this is not orange, and this is not orange. Does that mean that nothing is orange? Does it mean that something is orange is false? No, because of this, right? But if this is relevant only because it in fact is one of the objects that I'm talking about. So both the existential and the universal care about all of the objects, they just care about them in different ways. So these three facts about logical quantifiers, in the next video we're going to turn to natural quantifiers, and we're going to contrast these facts about logical quantifiers with facts about natural language quantifiers, and we're going to see that they're rather different. And that's the fundamental reason why, if you recall, I talked in the first video about the fact, or I mentioned the fact that the correspondence between English grammar, the grammar of English sentences, and the grammar of logical sentences that symbolize them is more complicated in Chapter 3 than in Chapters 1 and 2, and it's because of the ways in which logical quantifiers are different than natural language quantifiers. And so we'll see that in the next video.